Hey guys, so we are starting a brand new chapter on functions. And functions is probably a new concept for most of you, but it's one that you'll use throughout algebra, algebra 2, the rest of your higher level math. So this is something that you need to learn and understand because you will be seeing it again and again. So how do we relate an input to an output? For instance, if I have a relationship x plus 2 and the input is 3, then what is the output? Well, that lies in the concept of functions. Functions have three parts: inputs, relationships, and outputs. So think of it like cooking. We have an input, ingredients, we have a relationship, which is a recipe, and then an output, voila, our meal. You can think of it as a machine too. One number goes in, here's our relationship, multiply it by 2, a number comes out. So functions have one basic rule. One input cannot have multiple outputs. So if I input the number 1, I can't have two numbers come out. However, multiple inputs can have a singular output. So I input these two numbers, but only one number comes out. So as long as only one number comes out per input, then it is a function. Now we can graph our function. So this function, we can have a table to represent it. We can, from this table, make a list of ordered pairs, and we can take these ordered pairs and make a graph. So you're going to learn, and we're going to look at all these different representations for functions in this section. So you guys can turn to page 253 and follow along in your books. 253. So first of all, when two mathematical values are related in some way, we call that a relation. A relation is any set of ordered pairs. So any set of xy pairs. The input is the x coordinate, the output is the y coordinate. And we can represent relations in many different ways. So one way is ordered pairs. This is our relation. We have an x, we have a y. We can also take all these ordered pairs and write them in a table. You see all the x coordinates here and all the y coordinates here. We could also write that as what we call a mapping. So each x, we put them in order with each y, and then we draw arrows from the x to the y that it goes with. We can also take those 4 points and put them on a graph. So this is a relation, just any relationship between x and y, whether we write it as ordered pairs, a table, mapping, or graph. And we're going to be looking at all of these in this section here. Now a function is a specific type of relation in which each input has exactly one output. So here's an example of a function, because each x has only one y. This goes to only one output. But this would not be a function because 2 has two different outputs. So it's a relation, but it's not a function. So that's important, that you have to be able to identify what is a function and what is not a function. And it all comes down to each x can only have one y. So a mapping diagram we can use to determine whether a relation is a function, okay? So again, here's one that is a function, and here's one that's not a function. Again, we can see that this x has two different y's. This input has two different outputs there. All right, so let's see if we can figure this out now with a few examples here. Is this a function or not a function? What do you think? So if we look at this input, we see that there are two different outputs. And this relationship is not a function because that one is mapped to more than one output value here. So try the check problem. Let's let's look at another example and then we'll do the check problem. I'll have it paused for us. So look at this, each x, 1y, x, 1y, x, 1y. This x has 1y. Now, we can have an output repeated. You just can't have an input that has more than one output. So this one is a function because each input is mapped to exactly one output. So you can't, x can't have two y's, but a y can go with two separate x's. Each of these inputs has only one output. Okay, another way we can identify functions is with function tables. And this is on page 256. Oh my goodness, we have a lot of different ways that we're going to look at here. On page 256, we want to look at each input and make sure that it only has one output. So consider how the members of the input correspond to the members of the output. Here, each x is not repeated, and each x only has one y. But if you look here, the x's are repeated, and they have two different outputs. So 1 has two different outputs, and 3 has two different outputs. So that one would not be a function. So let's look at a few examples here. Sorry, this loads a little slow. If we look, each x only occurs once. Now, it doesn't matter that we have separate y's or the same y. This x only has one y. This x only has one y. This x only has one y. So x cannot be repeated, but y can be repeated. So are there any x values that correspond to more than one output? No, there's not. So this is a function because each input corresponds to exactly one output, and you can fill this in your book. All right, let's look at another example. So now, look at each input. Is there an x that has more than one output? If you look at it, 6 has two different outputs. So this one is not a function because the input 6 corresponds to more than one output. This one's not in your book, so you can try the check problem now. For this example, we'll pause and do that. And let's look at telling if something is a function using a graph now. Now, the ordered pairs of a relation can be graphed. To determine whether the relationship shown on a graph is a function, we can use something called the vertical line test. Because if for each x value a vertical line passes through no more than one point on the graph is a function. If it passes through more than one point, it's not a function. So essentially, if I take this vertical line and move it anywhere, there it goes. Will this vertical line ever touch more than one point on this graph? And in this case, the answer is no. This vertical line will never touch more than one point on the graph. And because a vertical line will always only touch one point, that one is a function. But for this one, if you notice, if I draw a vertical line, it's going to touch more than one point on a graph. And if you think about it, if it touches more than one point, then here, this point and this point have the same x coordinate, but they have different y coordinates. So each x has more than one y, which is why this one would not be a function. So the way to tell from a graph is if it passes the vertical line test. If I take this vertical line, no matter where it is on the graph, this only touches this green graph at one point. So this one would be a function. So this one's fairly simple. If you think about it, if I draw a vertical line anywhere on this graph, and I want to know if this is a function. Oh, no, that's it. Okay. Let's see. So if I were to draw a vertical line, then this graph is just these 5 points. point. So if I were to draw vertical lines, would I touch more than one point? And if you look right here, if I draw a vertical line here, it would touch 2 points. So this relationship is not a function, because if you look about here, this would be the point 2, 3, and this would be the point 2, negative 3. So the input 2 corresponds to more than one output. So this one is not a function. Let's look at another example, not in your book. Is this one a function? If I draw a vertical line here or here, oh, there we go. This vertical line touches more than one point because that output, at least one input has more than one output. So it doesn't matter if the rest of these are good. If there's any x that has more than one y, it is not a function. If I can draw a vertical line anywhere and it touches 2 points, it is not a function. So we can do that when we have just points or when our graph is a continuous line. So if I were to draw a vertical line anywhere here, what do you think? Is this a function or not a function? Does it pass through more than one point? No. So this one is a function. It passes the vertical line test. How about this one here? If I draw a vertical line anywhere on this graph, think about it, vertical lines anywhere, this one is or is not? Because each input has exactly one output. So this one is also a function. So you guys can try that last check problem, and then we'll practice some of this.